Hi guys, let's start talking about this acceleration equation. A little blurry, but we can see that it says in deep space, no gravity. The bolt, which is an arrow of a crossbow, accelerates, and it gives us an acceleration of 199 meters per second squared, attains a speed of 116 meters per second when it leaves the bow. For how long is it accelerating? So what we're searching for is we're searching for our delta t, or change in time. Now, what we have to look at is the information that it gives us and the information that it doesn't give us. So we'll first write down our given. It says that our acceleration equals 199 meters per second squared, and it says that and attains a speed of 116 meters per second when it leaves the bow. So when we're looking at this, that is not our initial velocity, but that's our final velocity. So our velocity final is going to equal 116 meters per second. The other thing that we have to think about is when we're picturing this, you have to picture somebody standing there with a crossbow. What is the bolt or the arrow? What is it moving, or how fast is it moving before the crossbow is fired? Well, when we think about it, before you pull the trigger of a crossbow, your initial velocity is going to be 0 meters per second because the arrow doesn't move before you pull the trigger. Okay, so we have acceleration, we have final velocity, we have initial velocity, and we're searching for our change in time. Okay, if we look on our equations, what we have is that our change in time, this equation is just going to be the regular old acceleration equation, where acceleration equals our final velocity minus our initial velocity all over change in time. It's the first acceleration equation that we really look at. So to solve this equation for change in time, all we have to do is switch acceleration and switch delta t. So we'll get the equation delta t equals our final velocity minus our initial velocity all over our acceleration. All we have to do from here is plug all of our variables in. So we get our final velocity is going to be 116 meters per second minus our 0 meters per second of our initial velocity all over our acceleration of 199 meters per second squared. Plug this into the calculator and we should get an answer of right around 0.5829, and since we're solving for time, we know that this unit will be seconds. Okay, that's the first question that we have in the set of 3 questions up there. One thing that I will tell you is realize, since there is no gravity, basically better put, since there's no friction in space, once the arrow is done accelerating, its final velocity when it leaves the crossbow is going to be its constant velocity afterwards. And so it's not going to increase in velocity past that 116 meters per second. And it's not going to slow down either because it's in space with no friction, so it has nothing opposing its speed, its velocity. So it'll stay at 116 meters per second. And that should help you as you do the other questions.